everybody's awake? Right, so as Carsten mentioned, we have a really large crowd participating into this testing. We have finished this testing in Berlin a couple of weeks back. Yeah, so it's really interesting use case for those who think they require to extend their networks to be like more than one domain, like multi-domain networks. This is where we have the BGP stuff, and let's see how it helps us to make this network not only be scalable, but as well fast in convergence. We'll see how faster route kicks in when we have inter-AS connectivity. For this to be possible, we used a relatively new stuff, which is called Anycast next hops with BGP prefix seed. So this has been standardized at IETF. You see the RFC number. And it's called BGP-SR prefix segment identifier extension. So we use here a label index TLV, which is mandatory for this to work. An optional thing that we have introduced and tested as well successfully is sending sRGB as well in the BGP update so that we know what is the global base on the other side. And then we set the BGP advertisements towards our PE devices with next hop to some Anycast IP address. So it's kind of fake Anycast IP address, which can be advertised by multiple ASBRs at the same time. The important thing to note is that the dynamic label in BGP-LU would be replaced by the resulting global SR label and not be dynamic anymore. And then another part is ISIS as a protocol that we tested, but of course possible as well with OSPF, is that we advertised in labeled ISIS, Anycast IP address and prefix seed, so that the guys within our domain know how to reach the ASBR. That's simple. MPLS data plane is used for this testing, so we use the labeled unicast as you know it for many years. So then what would be the value for any service provider to think of this technology and maybe start adopting this? Well, first you get the TI-LFA kicking in case your ASBR or link to the ASBR is failing. So what was previously triggered by BGP convergence can now be triggered by IGP convergence. And the restoration time is surely much faster. We have as well troubleshooting facilitated with this technology that we can use the global labels across multiple domains. We still use BGP option C as we like it, as we love it. And yeah, we can use just a single ASBR to stitch two domains. Of course, we can use multiple similar stitching ASBRs to provide redundancy. And this is exactly the goal of our test. So you will see later how the topology looks like with multiple redundant ASBRs. So how this is working in a nutshell. So first, a little bit of history. Like imagine PE1 is advertising BGP-LU prefixes to the ASBRs, and those ASBRs re-advertise to the other domain. So this is a single stitching ASBR. And both ASBRs, if you see it on the right side, different colors, they allocated some dynamic labels, which are of course different. So what happens in the case of a failure of some ASBR is that the PE2 on the right side, it needs to wait until BGP convergence kicks in so that it redirects traffic to the other remaining ASBR. Because otherwise, if it would start sending traffic to the other remaining ASBR with the label of ASBR1, it will not work because ASBR2 doesn't have any understanding, any context for this label. So now, how to make it better? You see everything is now green. So we make it better by using the global SID for PE1 and re-advertising it in BGP-LU with prefix SID. So both ASBRs, 1 and 2, would re-advertise the address with the same label towards the right domain. So now whenever we have a failure on the data plane or on the ASBR, the P2 as a router in the middle, a transit router, would be able to use, for example, TI-LFA to switch traffic rapidly towards the remaining ASBR. So this is in a nutshell how it works. And of course, we want to show you the topology and to show the live demo. And this is where I give the floor to my colleague Victor to continue with the topology.
Hello, everyone. So here is the test topology you can see on this diagram. In fact, it's not complex from one side, but it's complex from the other side. I mean that many vendors were participating in this test, so that's a pure interworking for many vendors. So, and you can see here that we have left domain and right domain with a different autonomous system. We have some PEs on the left, on the right. Then we have two road reflector for VPN, IPv4 and IPv6 roads in different domains. But then we should stitch this domain, but with the BGP-LU. So how it's done? Normally we have session, BGP-LU session from each ASBR to each PE device on the right-hand side and on the left-hand side. As previously mentioned, we have the Anycast IP address configured on all ASBRs. And this Anycast IP address uses the label from MPLS seed range from sRGB. So the test procedure. So first of all, we need to configure labeled ISIS or SR-ISIS and verify the database and SR-TLV with a loopback and prefix seeds. Step 2, we should configure L3 VPN as usual with option C for inter-AS, and road reflectors are peering across AS boundaries. ASBRs writes as a stitching node in line with road reflector for BGP-LU with a prefix seed. Again, important point that we use BGP label the same as we use in the ISIS domain, and this label is preserved end-to-end between two autonomous systems. Also, on control plane, we advertise the prefix seed and sRGB in BGP advertisement. ISIS metric on P node force traffic to the right ASBR, and upon on ASBR failure, the traffic use faster route inside the autonomous system to the other ASBR. Okay, now the time of live demo. Okay, so let's start logically from PE. So here is the PE configuration. Here you can see the advertisement of a local loopback address that use the IPv4 BGP-LU label, the same as is used in the SR-ISIS. Also, you can see here at the bottom the prefix seed with index and originator sRGB TLV. Next step, I just want to show you that we indeed use the same PLU label BGP seed, the same seed as we use in SR-ISIS on this node. Next one, we received the BGP-LU route from the neighboring autonomous system. So it's the address of P node on the neighboring autonomous system. And you can see here that we use IPv4 label. Again, it's from sRGB label block, it's 20031. And also we received this prefix seed TLV with index and originator sRGB. You can see here the tunnel table. So here, what I want to highlight here, so there are some BGP-LU roads received from neighboring ASBR that you can see owner BGP. But it resolved to the next hop of Anycast IP address with Anycast seed is 209, 209, 209, 201. Okay, if we inspect this, you can see here that tunnel label is from sRGB label block, is 20.20.01. That's again the remote P node that again use the label from sRGB label block end-to-end between these two autonomous systems. And the last command is we can check that in L3 VPN, in VPRN, we have the routes resolved via BGP-LU with using this BGP seed with the next hop to Anycast seed. Okay, next step would be the configuration demo on the ASBR side, and I hand over to Christoph.
Hello, good morning, everyone. So the configurations, yes, as it has been mentioned on the ASBR side, the goal was to segregate both domains, right? So we had configured two ISIS instances and make the necessary stuff in order to advertise only what each region should see, okay? So for that, we have two instances, right? Classical instance, and then on the not seed side, the goal was to generate, okay, your a prefix, yes, an Anycast seed through the common Anycast IP, which is this one. So we have all those prefixes, right, on each domain, and then, okay, let me retrieve this thing. So on each domain, the goal was to generate this Anycast loopback here that is shared between all the ASBR, so 209, 209, 209, 201, right, on both sides, and advertise the right label. We obviously have different Anycast IP on both domains. So, and from the BGP-LU side, the goal was to just reflect the LU route coming from one domain to the other domain. So what could be interesting to see is what we receive from Nokia, for instance, from 206, this node, right? And we get the index, okay, we get the sRGB, and then from the reflection point of view, the goal was to send that route to the other side, to the other domain, by changing the next hop and putting as the IP for the next hop this Anycast IP, okay? And then the other domain could resolve recursively that the other domains should be joined with this label as a transport label. Okay, so it means that from the PE side of things, there will be 3 labels when sending the traffic to the other domain. Label number 1 will be this one. Label number 2 is the local transport label. And label number 3, obviously, is the services label.
Thanks, Christoph. So now time to do some bad things happen. So we can see how traffic is broken and then how it is restored. So I'm showing now a different ASBR flowing over interfaces over one ASBR, which is currently a primary ASBR. What we'll do, we'll drop the 2 interfaces towards both ASs. So we'll drop the interfaces towards both left and right AS numbers on ASBR, simulating kind of fiber break or maybe ASBR outage completely. So it should be a rollback 1. Show compare. Usually you should do this as well. And then that's all I do. Well, after this happens, we will see actually no traffic on this ASBR, which is obvious because, well, it's drained because of outage on both interfaces. Well, and now it's time to see the results, how it worked on the tester, because we have, of course, tester sending live traffic and showing us what was exactly happening. And with this, I invite Malak to show this part.
Thank you, Anton. Good morning, everyone. So we participated as Keysight, both as PE and traffic generation in this test. Unlike my peers, I don't have CLIs to show you, but a beautiful, I would say, topology with colorful parts. So here for the PE side, we have emulated the whole topology, and we have established BGP-LU session with both Arista and Juniper. And with the retrieved information, we get the labels that is authorized by both the ASBRs and also the IPv4 Anycast IPs. We also retrieved through Juniper spine the correct labels, and with all these labels, Keysight can generate traffic and send it to the other side PEs from the other ASBR part. Now, as you can see that after Anton did the shutdown, it translates in Keysight for us as PEs that the BGP-LU session with Juniper went down, which is red, and the traffic is solely flowing through Arista's ASBR. Now for the traffic, to confirm what Anton said, that we are generating 3 flows bidirectional for the 3 PEs, and we are sending just basic traffic with 10,000 frames per second. And when the conversions happened, you can see that we have a very slight loss, insignificant loss, we can say, and the traffic is now flowing through Arista. Thank you. Now back to Anton.
Thanks, Malak. Right, so just as a short summary, what we tried to achieve with this test. So we have shifted convergence from BGP towards IGP. And this happens really, really fast. So if you don't tune your BGP and leave it by default, then the timers for BGP will take much longer time to understand that the ASBR is not reachable anymore, and to kick in the, the convergence and to send traffic towards the right destination. With having this convergence on IGP, we have successfully demonstrated that the outage was perfectly within 50 milliseconds because we had a TILFA kicking in on fiber outage or an SBR outage. And this all is accompanied by the fact that you don't need to redistribute in IGP PE addresses from the other domain. So you don't overload your IGP, you just use for this remote domain, for example, one single Anycast IP address accompanied with one single label, and your network is becoming more stable and converges faster. Yeah, with this, this demo is finished.